Well, thanks for coming. Today we'll spend a little bit of time talking remote monitoring and really a little bit more automation in the sugar bush. We'll be interested to hear, sure, a couple different stories. I'll start just a quick story about myself, where remote monitoring fits in for our sugaring operation, a little bit more about my background. We'd love to hear some of your needs as well in your sugar bush, what you're interested in, what problems you have, see how we can best meet your needs as well. So my background, I basically grew up on a dairy farm in Wisconsin. So my entire childhood, outdoors, manual labor, picking rocks, baling hay, milking the cows, feeding the cows. That was my upbringing, and I'm really blessed to have that type of upbringing. Went to school for engineering in Madison. I now work in the corporate world in a manufacturing company. I like what I do, more in the data systems, electrical engineering for that company. Very much enjoy what I do, but it's stuck in the corporate world in the confines of concrete walls and manufacturing facilities. So like many of us, to escape the confines of behind a monitor all day long, working inside all day long, about 10 years ago, my brother had the crazy idea to do maple syrup. What started as a couple taps in the backyard quickly turned into, we did the bags and buckets for 3 or 4 years. Then we did 3/16 just gravity, trying to save us time and energy of collecting all of that sap. Started with 3/16 gravity. That was great. That was great. Let's add more tubing. Did more tubing of 3/16. Did some 5/16. Added some vacuum pumps. And overall, over the years, our operation kept, I say growing, but trying to, be more efficient in this collection of sap from our sugaring operation. With that, we now have about 2,000 taps split across 2 different sugar bushes. One's about 500 taps, the other's 1,500 taps. That's the size of our operation. When we did tubing systems, the particular story I can recall, so as we have tubing systems, vacuum pumps, collection systems in our sugar bush, this particular day, I'm stuck inside my office at work. I look outside, it's sunny and it's about 39 degrees, 40 degrees. My thought is the tank's gonna overflow. I better get my butt out there, leave work early, go home, kind of blow off my family. So I kind of pissed off my boss for missing the last meeting of the day. I get home, I hear my wife made this nice dinner. I say, I gotta go. So I blow her off. I run out to the sugar bush. There's our collection tank. So I drive about a half an hour out there. I live about half an hour from our home farm, which is now our sugar house. Drive another mile or 2 to the sugar bush, and the tank's only half full. So I pissed off the wife. I pissed off my boss, and yeah, we had some sap that day, but I didn't know the operation was only half full. I could have kept my boss happy, could have kept my wife happy, and that's really where the first inkling of, man, I got to somehow monitor that operation. About a week later, now I think on a 39-degree day, it's sunny, the tank's not going to be that full that day. So I work a full day, have a quick dinner with my wife, wife and family. I run out there. Now the tank's overflowing, and there's sap on the ground. And so just money sitting on the ground that I wasted, not knowing the status of our operation. The next season, I wasn't smart enough yet to make Sap Spy or purchase a monitoring system. More mechanical releasers and vacuum pumps. Anybody who runs a mechanical releaser has had these experiences, whereas similar scenario, a great sugaring day. I took a half day that day, thinking it's going to be a good solid sap run that day. I run out to the sugar bush, thinking that tank's going to be overflowing. To come to find out, my mechanical releaser hung up and never reset itself, and so the woods had almost no vacuum the majority of that day. And so instead of a full tank, we had half to maybe a quarter tank just of what we had in gravity. Those were all the problems I think we all try to solve with monitoring systems. I think of monitoring and more automation in the sugar bush is how do we best leverage data to solve problems and make decisions? How do we both save ourselves time, give us peace of mind of how the sugar bush is operating, and then how do we maximize a little bit of our production? If I talk monitoring systems, I think of it as kind of hierarchy of needs. Just like you and I, as living humans, right? We need food, water, shelter, and then more and more needs, whether it's a TV, a cell phone, a car to drive. It's kind of that hierarchy of needs, very similar to the sugaring operation and monitoring systems. That foundational need to really maximize production, give you peace of mind. Maybe that foundational need just for you is just vacuum monitoring. To me, that's one of the most critical is vacuum and then tank level. Is my vacuum pump working like it should? If you're on a gas engine pump, did it run out of gas? Did that motor have a problem? Is my releaser working like it should? Especially mechanical releasers will hang up quite often or have other problems. Or maybe my moisture trap filled with sap and it cut off vacuum to the sugar bush. So that is the vacuum in the woods at its peak performance? So are those things operational? Do we have any major leaks in our operation? Major leaks in the system. As we have less vacuum, obviously you're going to get less sap. So that's one of that foundational needs is what is the vacuum level you have in your sugar bush. The next, likely is the tank level. Back to my earlier comment, if we're overflowing sap in your tank, that's all just money on the ground that you're not getting. So knowing that tank level is both, is the tank going to overflow? I've done it several times before monitoring as well. You pump out that tank the night before, you close that valve in the tank before it starts flowing the next day. That's another critical piece of monitoring that tank. So those, vacuum level, tank level, bonus is temperature. Yeah, we can monitor that at home. Maybe we're not right in the sugar bush, but what is that temperature? How cold did it get last night? How warm is it right now? Helps you judge how good is that sap flow going to be for that day. So knowing that temperature is another good bonus that you have. You can put any number you want to it. Everybody's going to have a different number. To me, knowing those three things, my vacuum, my tank level, and temperature, to me that's 70-80% of the problem I try to solve with monitoring systems. That's if your vacuum pump shuts off, you get very little sap that day. If your tank's overflowing, you missed out. If you didn't close that valve, there's no sap that day. We all spent good money on installing tubing systems in our sugar bush. Spent good money on a high-end vacuum pump, on a releaser to try to maximize our productivity out of the sugar bush. It's those few, 1 or 2 days of missing some production. You missed out on a lot of that opportunity that you could have had if you know those issues existed. So that's really a lot of the benefit of monitoring systems come in is those few good sap days. If you miss out pretty quickly, you can justify a monitoring system. So at the core, it's that tank level, vacuum, and temperature of your sugar bush. Knowing those few things. That back to that hierarchy of needs. To me, that's like maybe not water, but like food and necessity. Knowing those few things is one of the key necessities of a monitoring system. Beyond that, now it's more personal preference, or depending on how many taps you guys are operating. It's beyond that. It's now if I have a leak somewhere in my sugar bush, where is that leak? How quickly can I go address that leak? How much time as a person? What's my time worth? That instead of 2 hours to go find that leak on the main line, can monitoring help me find where that leak is, pinpoint me what main line to go down to address that, and as long as it takes me to walk out to that woods, rather than spending hours trying to hunt down that leak. So that's that next evolution or that next hierarchy of needs in monitoring systems. Any questions so far? Yeah, go ahead.
What's the average cost for a monitoring system?
Yeah, so it's a wide variety of different systems out there. If you go from Sap Spy is what I personally do. My background's engineering, technical. I basically started this 4 years ago, building out that product. Our kind of core offering is $895 for a tank, temperature, and vacuum. It's about $900 to get started with Sap Spy. Other systems, I know Sap Check is similar in price, different functionality, more simple, just texting back and forth. CDL, H2O, LaPierre, they all make equivalent, or trying to address a similar need. Because my opinion, it's maybe a little biased, but my opinion, they're trying to meet the needs of that largest producer, guys with hundreds of acres, tens of thousands of taps. So their price point's going to be higher, and typically they will require Wi-Fi and power in the sugar bush. So their price points, I think introductory, I hate to give a price, I'm not even sure, but around $1,500 to $2,000 I think is where their introductory price point is, in that range. Yeah. And so it depends on how many taps. Like I personally have 1,500 taps in one of our operations. On those good sap flowing days, if I missed out on one of those good sap flowing days where I'm getting a gallon or more per tap, that itself is paying for the monitoring system. And it's I think of monitoring as both the increase of production. You can get more sap from your sugar bush by having monitoring systems, but secondly, your time and just peace of mind. Like the event where I ran out there, my moisture trap is full. It sucked up the ball. My woods had no vacuum that day. Yes, I missed out on sap that day, but that's a memory I'll never forget. So that night, I'm not sleeping very well. The next sap flow, I'm like checking the woods 2 or 3 times during the day so I don't get in that same event, same scenario. And so it's that condition, you kind of get scarred by those memories, and then you always think about it. You're kind of stressed about it. Is that woods working like it should or not? I'm driving back and forth unnecessarily. I'm, that's the scars that you have. So I burn more time of my day by having those worries.
So for the vacuum monitoring, your system, I presume, is base model is like right outside the vacuum.
Yeah. So where Sap Spy is trying to address is that a few hundred taps, several thousand taps in a sugar bush. And it's typically the sensor hub is what we refer to it as. It's one device that does vacuum on a 5/16 port on the bottom, tank level, the ultrasonic sensor here. So that's you'll put this above the tank. It sends out an ultrasound to say how far is that liquid away, to tell you how full that tank is from 0 to 100%. And then a temperature probe, either sticking here or it's a 3-foot cable. We have options for both. So monitor those three things. This typically for most customers is right at your tank, your main collection system. This obviously is above the tank. The vacuum line typically will hook up right to the releaser itself on the woods side of the releaser. It can go right to the main line as well, but typically right at the releaser. So you know what vacuum you have in your sugar bush. Yeah, we do text alerts. So I guess my phone's recording, but on the phone you can set up to text 3 different numbers for both loss of power. So maybe on a generator, you have this connected to the generator. It'll text for loss of power. It'll text for loss of vacuum, full tank level, those, and low battery is the 3 that it'll send a text for. It'll send those texts up to 3 numbers. That way you don't always have to have your phone open to always look at the data. Maybe your boss is yelling at you for having your phone always open or having always on the web. So rather than that, it's just send you a text alert upon those conditions. And you can set those thresholds, whatever vacuum level you want, whatever a full tank means to you. You essentially can set those thresholds right in the app. And it'll also plot that data over time. So like vacuum level, maybe your releaser's on the fringe where it hangs up a little bit and a minute or 2 later it frees up and then it has an issue. By plotting that data over time, you kind of see the health of your releaser, the health of your vacuum system, of how that's working for you. And so that kind of core offering is that sensor hub right at your tank. And it's for us new this year is what we refer to as sensor nodes. So this is kind of that hierarchy of needs. If I have a leak, my vacuum at the releaser is going to drop a little bit. Maybe it's half an inch, maybe it's an inch or two. It depends how big a leak is. At this point, I know I have a leak in my sugar bush. I can go turn valves off, go check different gauges, run back and forth, try to hear the leak, try to find it, to spend hours to do it. New this year, we have sensor nodes, which a sensor node, well, a couple different varieties of this. We have a single vacuum port sensor node, a dual port sensor node, and then a vacuum port and a tank level sensor as a sensor node as an all-in-one. This typically is used for your end of your main lines. So the end of every main line, you would put measure a vacuum at the end of that main line. The dual ports this would be one main line, this would be the other one that's close by. Put this in the middle, run 5/16 in between to monitor the end of both of those. Two different advantages there. One is when you have a leak, well, that's going to be the main line with the lowest vacuum. So you know right where to go down that main line somewhere there's that leak. The other aspect is, especially with flatter ground, if you have any dips or sags in that run, if you have a leaky saddle, some air coming in right where that saddle is, that main line is going to freeze up hard in the morning, and you'll see that vacuum at the end is not going to pick up until it thaws out quite a bit, and then you know that main line, either a leaky saddle, maybe a dip in it somewhere, to get more sap out of that main line. You know what? There's an issue there that you have to go correct. With a smaller group here, you mind if you're open to it, just sharing, how many taps you have, you're in tubing, looking at it. Where are you guys at?
We're on tubing.
Okay.
We're definitely a small operation.
Yeah.
About 150 taps right now.
Yeah, nice.
Grow a little bit. But I'm in the same boat as you. I've got a job.
Yep.
Sitting in front of the monitor and feeding that all day.
Yep. How do I know what the sugar wish is doing? Yep, absolutely.
So that's kind of my biggest reason for looking at it.
Yeah.
Now, you don't have any opportunity to say like, oh, I'm at 3/4 full. I can now kick on my RO pump and that starts providing.
Yep, that's a great question. I'm ready to fire up. So there's more on the automation side of things. For that scenario, we do have an option to turn a relay on and off. So all from the phone, I can turn that relay on and off. So pretty easily, I can monitor, 2 o'clock, 3 o'clock. I can flip open the phone, see my tanks at 3/4 full, flip on a relay. That relay will then fire up your RO to get that operational. Yep, certainly. Yeah, go ahead. Yeah, this is a great question. Yeah, so our goal is at Sap Spy. I'll speak for me. That's what I know. The other guys are Wi-Fi. Sap Check is also cellular. But like LaPierre, CDL, H2O, they're all Wi-Fi. To me, that was the hang-up of why I went down and built my own. I don't have Wi-Fi in my sugar bush, right? A lot of us don't, especially remote sugar bushes. And so that's where we went down the route of cellular to start. We'll have Wi-Fi in the future, but cellular to start, as that's what a lot of the unmet need in the market was cellular connectivity. Our goal, though, is simple and affordable. Keeping it simple means that I don't want, a lot of guys, it's kind of a pain to go with the SIM card and what carriers do I go to? How do I ask my carrier for an extra SIM card? There's a lot of complexity in that piece. So for us to keep it simple, we handle all that complexity for you. All you have to do is bring this to your sugar bush, turn it on, and it'll connect to the cell tower there. We work off of AT&T on current hardware. Special circumstances, we can use different hardware, same cost, but AT&T, T-Mobile, and US Cellular, and it'll connect to any three of those. The cost for us is the first season is included in the price of Sap Spy. Future seasons, it's $50 per season. So the whole activation, deactivation, all of those fees, the cellular connectivity fee, that's all kind of wrapped into that $50 per season. and then we handle the deactivation and activation of that. We'll activate early January, deactivate 1st of May. But it's all about keeping it simple for that end user. So we try to handle all that complexity for you.
Now, you don't have to increase that per node, or
It's per sensor hub is where we're at. Nodes are, still. So we're a limited release of sensor nodes. This is more of an area where we intend on continue to expand in the future. Have more offerings in the future for sensor nodes. We had early adopters last season. So this is kind of our commercial product. Like to get this in the hands of enough producers to know we have the design right, and then push harder and harder on this and continue to evolve this in the future.
What's the range on that?
Price-wise or miles? Or between the two? Yeah, so we're, I say confidently a quarter mile. It can go up to a half a mile, and that's like straight through a sugar bush, through the trees, through the terrain. If it's line of sight, like if I put this 60 feet high on top of a silo, it can go 3 miles. So a lot of it's got to do with terrain. If it's call it earth or dirt in between a sensor node and a sensor hub, then it's going to knock down the range a decent amount. Where it's through the trees, through a sugar bush, a quarter mile is pretty safe.
Well, can you add another one to that? Will it repeat off that one?
Our current offering this year, and this is partly why we're a limited release, is the every sensor node. It's keeping it simple. Every sensor node talks to the sensor hub. Based on the customers we have this year with sensor nodes, we evaluate: do we go mesh? Do we do repeaters? What's the right way to cover most of the needs? And we're really trying to best meet the needs of a couple hundred taps to several thousand taps in a sugar bush. So most times we're talking 40 acres, maybe 80 acres, maybe up to 100 depending on the producer. And then depends on where you put the sensor hub. It's a quarter mile safely in any direction. That covers a decent amount of the producers. So we're debating: do we go mesh? Do we go repeaters? If that's the market we're really trying to meet, does it really make sense to add that complexity? There's a lot of complexity with mesh networking. So that's what we're going to learn this year. Price rise for these, at least for this first year, we're at $325 for a single vacuum port, $395, basically $400 for a dual vacuum, and then that additional tank is $595 for a vacuum port and tank level sensor on a node. One of the main reasons we had that additional tank on a node is a couple guys, will have, right, the tank is always in the lowest part of the woods. That lowest part of the woods, maybe you don't have the best cell phone reception in that lowest part of the woods. And so I have a couple different customers where they'll put the sensor hub without the tank level sensor, and then use this in the higher part of the woods at the end of one of their main lines. In that scenario, they can still monitor vacuum at that main line where they have good cell phone reception, and then reach down in the valley where the cell phone reception just isn't there with the sensor node. So they can still use Sap Spy in this monitoring system where they don't have good cell phone reception right at their tank. So that's one of the main reasons we have the sensor node with that configuration.
Is it going to have power to it then?
Yeah, good question. Sensor hub, so the technology we use is intended for like sensors like this. The first part of that is low power. It's somewhere between what your cell phone uses and what call a sensor node or a low power device uses. It has an internal battery. That battery will last 2 to 4 weeks, completely by itself, no power on it. Different options we have, and I have them at my table over there. One is solar panel. So you can just plug a solar panel right into it, and that'll keep the battery inside charged. Many guys will, it's just a USB plug. The standard cable that comes with it is just a USB cable that'll plug right into any USB battery pack or a wall charger. So you can bring it in 1 or 2 times during the season, get it a full charge, bring it back out, and away you go. Solar panel or 12 volt 12-volt alligator clips. So you guys provide the battery, we provide the cable that plugs into here and snaps on a battery. I'd say it's 12-volt battery will certainly last all season, yeah. Just the internal battery is 2 to 4 weeks. so it'll certainly last all season. And that 2 to 4 weeks is kind of based on signal strength and then what mode of operation you want to have it in. In this, I call it normal mode or standard mode. Most times you don't need readings, immediately. So in that scenario, it wakes itself up, takes readings every 5 minutes. It remembers those readings. Every 20 minutes, it'll wake up, take readings, and then turn on the cellular piece and publish all that data out. So what I mean by that is every 5 minutes you get a data point. The data refreshes every 20 minutes when it's on battery and in that normal mode. So every 20 minutes you get to see the data over the last every 5 minutes. When it's you can also flip to different modes. So I call it normal mode. Every 20 minutes it wakes up, talks to the internet, talks to the application. Maybe you're checking leaks in the woods. Like, where is that leak? I just have a sensor hub. I want to go find. I corrected the leak. Did I make a difference? We have a couple different. You can put it into an always-on mode. Then you can, on the app, you can hit that app as many times as you want and immediately get the reading. How am I doing? You can also put it into what I call burst mode, where instead of every 5 minutes, it'll take a reading every 1 minute. Every minute it takes a reading and pushes that data out. And so when I'm finding leaks, many times I'll flip it to burst mode, and then be able to walk the woods, go find some leaks, look at my app. Okay, yep, I gained a half an inch. Go find another leak. Okay, I gained another inch. So that's another mode of operation we have. And about that 2 to 4 weeks too. I think if a producer is wants to get it through the entire season without having to recharge it or without having a battery or a solar panel, we also have what's called cold weather deep sleep. So it freezes up for 2-3 days, or at night it's going to be frozen all night long. Well, I don't need data from it. I know the sap's not going to run. You put it in this cold weather deep sleep. In that mode, it's every 20 minutes it'll take a reading, and every 2 hours it'll wake up and push the data out. So when it's frozen hard, I put it into that setting. So every 2 hours I get a chance to switch modes, and I still get some data. In that mode, I had one of the customers leave it in that mode all season, and it just finally died like a week or two ago. So since April, it's been running in that mode the entire time. So it's if you want to spend a little time switching between modes based on your needs, obviously burst mode, pushing out data every minute, is going to use a little bit more battery than pushing out data every 2 hours. So you can switch between modes to help kind of budget your battery. And what's very common, what I personally do in one of my sugar bushes, I don't even bother with a solar panel in my own. With the hookup on the bottom, USB cable, right? So everybody's drilling holes in their trees with DeWalt, Milwaukee, Roy-B, you name it. Somebody's using some power tool. They all have a USB adapter for it. And one time during the season, maybe twice if I have to, I'll just bring that out there, hook it up to the USB cable, leave this completely hooked up in the sugar bush, and about 2 to 3 hours, maybe 4 hours, it'll fully charge that battery again and get you another 2 to 4 weeks. That's most common, especially with guys without power. It's do I need alligator clips? Well, then I'll lug a battery out there. It's $100 for a solar panel. It's kind of trade-offs between you want a little bit of hassle of recharging it once or twice, or just go with a solar panel or 12-volt battery.